to the deep dive. Even for those of us who try to keep up, the AI space can feel like, well, just a constant stream of new terms, new breakthroughs. It gets confusing fast.
It really does.
So today, we're going to dive into some foundational material, a course actually on AI. We want to
Mm.
pull out those key ideas that, cut through the noise and really explain why things are moving so fast right now.
Yeah, and what's great about this source material is how it defines things, using this really helpful analogy, thinking of AI, machine learning, and deep learning like Russian nesting dolls.
Oh, okay. I like that.
Right. So we can sort of peel back each layer, understand what each one actually is, how they fit together, and then crucially, why AI seems to be everywhere all of a sudden.
Okay, let's do that. Using that nesting doll idea then, let's start with the biggest doll, the outside layer. When the course talks about artificial intelligence, AI itself, what's the core idea there?
Right. So AI is the big umbrella term. It's essentially about building machines, computer systems that can do tasks that usually require human intelligence, like thinking or learning.
Exactly. Things like reasoning, learning, solving problems, even understanding language or, visual perception, seeing things. It's the whole grand vision of making machines intelligent.
Got it. So AI is the big picture. Where does machine learning, ML, fit in? How does the source place that inside the AI doll?
Okay, so ML is that first really important doll nested inside AI.
Yeah.
And the key difference here is instead of programming a machine with explicit instructions for every single possibility,
Which would be impossible for complex tasks.
totally impossible.
Yeah.
Instead, machine learning lets the machine learn patterns directly from data. Lots and lots of data.
So, like the example you mentioned earlier, cats and dogs.
Exactly like that. You feed it thousands of images labeled cat or dog, and the algorithm itself figures out the important features, the patterns that distinguish them. It learns.
Yeah.
And then, crucially, can look at a new image it's never seen before and make a pretty good prediction. And its performance actually gets better the more data you give it. Right. More data, better learning. Okay. And then the course gets into deep learning, DL. This seems to be where a lot of the really dramatic progress is happening lately. How does that fit?
Precisely. Deep learning is like the innermost doll, a specialized and honestly really powerful type of machine learning.
Yeah.
It uses something called artificial neural networks, which are, well, loosely inspired by the structure of the human brain.
With lots of layers.
Exactly. They have multiple layers, sometimes many layers. That's the deep part. And these deep networks are incredibly good at finding really complex, subtle patterns, especially in messy, unstructured data.
Unstructured data like images, text.
Yeah, perfect examples: images, audio signals, natural language text, stuff that doesn't fit neatly into spreadsheets. Deep learning can kind of make sense of that raw data in a way that older ML methods struggled with. The depth allows it to learn features at different levels of abstraction.
It's amazing how quickly this has taken off. But you hear that the term AI itself is actually quite old, right? Like from the 1950s.
Yeah, 1956, the Dartmouth workshop. The term's been around for ages.
So the course must address this.
Yeah.
Why the explosion now? What changed to make deep learning, especially, so effective recently?
That's a really critical point the source makes. It basically boils down to two main things converging. First, big data. Just the sheer unprecedented amount of data we now generate from, the internet, phones, sensors, everything.
Fuel for the learning algorithms.
Exactly. These algorithms, especially deep neural networks, are data hungry. They thrive on massive data sets. And second, a huge leap in computational power, specifically GPUs.
Graphics cards, like for video games.
Yeah, graphics processing units. They were originally designed for rendering complex graphics in games, but it turns out their architecture, which can do lots of calculations in parallel, is perfect for the kind of math needed to train these deep neural networks efficiently.
So massive data means massive suitable computing power.
That's the magic combination that really ignited the modern AI, and particularly the deep learning revolution. It's kind of mind-blowing when you think about the scale of data needed and processed.
Okay, so we have these powerful techniques fueled by data and computing. What does this mean for us day to day? The course talks about different types of AI, narrow, general, super. What's the key takeaway there?
The absolute crucial point, and the source is very clear on this, is that all the AI we have today, everything you interact with, is artificial narrow intelligence, ANI, full stop.
also called weak AI.
Exactly. Weak
Yeah.
AI. It means the AI is designed and trained for one specific task or a very limited set of tasks. It operates within a predefined context and it simply cannot do things outside its domain.
So my spam filter can't suddenly start composing music.
Not a chance. It's brilliant at identifying spam, but that's it. Other examples are everywhere. Think about Siri or Alexa understanding your voice commands, facial recognition unlocking your phone, maybe even the systems in self-driving cars. They are all ANI.
And the other types, general and super AI.
Artificial General Intelligence, AGI, would be AI with human-level cognitive abilities across the board. Artificial Superintelligence, ASI, would surpass human intelligence. The source emphasizes these are purely theoretical at this point. We are nowhere near AGI, let alone ASI.
Right, so it's important to keep that distinction clear. Even though it's narrow, AI is clearly having a massive impact already. The course highlights examples across industries.
Oh, absolutely. Even as ANI, it's transformative. In healthcare, you've got AI analyzing medical scans like x rays or MRIs, sometimes spotting signs of diseases like cancer earlier or faster than a human might.
Incredible. And in finance.
And finance is huge for things like fraud detection, spotting suspicious transactions in real time. Also, for algorithmic trading, credit scoring, risk assessment, lots of data heavy tasks.
It really is becoming embedded everywhere.
It is. Think about retail. Those recommendation engines on Amazon or Netflix that uncannily know what you might want to buy or watch next, that's ML, often deep learning working behind the scenes.
And entertainment too, right? Like my social media feeds.
Definitely. The curation of your TikTok For You page is pure AI. And now we're even seeing AI creating content, generating novel images from text prompts, composing music. It's changing content creation and consumption fundamentally. And yeah, back to the spam filter, still a hero.
Okay, so let's quickly recap that nesting doll idea. AI is the biggest concept in intelligent machines. Inside that is machine learning systems that learn from data. And nested inside that is deep learning using those complex, deep neural networks, especially powerful for unstructured data.
Perfect summary. And the current boom, we learned, is really driven by that combination of big data and powerful GPU computing.
And crucially, remember that all the AI you encounter today, no matter how smart it seems, is artificial narrow intelligence designed for specific jobs. But even so, it's delivering huge value across pretty much every major sector.
Which leads to maybe a final thought for you, the listener, to chew on. As this narrow AI gets even better, even more integrated into everything, what new problems could you see it tackling in the next, say, 5 years?
Hmm. That's a great question.
How might that start to change your daily life in ways maybe we haven't even thought of yet?
Definitely something to think about. Thanks for diving deep with us today.